Welcome to Evolution in Controls. I'm your host, Tim Wilson. Thank you for joining us. In the fast-paced world of industrial automation, it's become commonplace to talk about packages or products moving faster and faster. In some respects, it gets easier and easier to make them go faster. But what doesn't get as much attention is that as it's easier and easier to make them go faster, it gets harder and harder to gather accurate information about them as they travel. Speed and efficiency aren't just about the mechanical functioning of machines. It is also about the accurate and consistent recognition, collection, and recording of data about the products and packages. It's ironic that the visual collection of information in a product delivery system is often the unseen element. In the past, the barrier to faster systems was the mechanical mechanisms that moved the product. Today, the challenge is data management. How do we collect, organize, and manage the data stream? It's no good moving products faster if we can't capture and handle the information about the product. Enter the scan tunnel, a solution designed for the collection of a significant amount of visual data that outperforms even the fastest of the delivery systems. And it's not just about the collection of a significant amount of visual data. The speed of the collection must be matched by the speed of the processing of that data. This isn't your average scanning system. But how does this technology transform the way we approach data management in industrial settings? Here to talk about the scan tunnel as not just a tool, but as a game changer in the realm of automation is Mr. Mark Berndt. Mark is the founder of Simple Vision Technology, and he's going to help us answer questions about the capabilities of the scan tunnel. Mark, thank you for joining us.
Thanks for having me.
Why don't we start? Tell us a little bit about yourself and then maybe Simple Vision Technology.
So I have over 27 years experience in the automation manufacturing industry. I have over 9 years of experience in the machine vision industry, and just over 3.5 years ago, we started Simple Vision Technology as a software company.
Okay, so what does Simple Vision Technology do?
Simple Vision Technology is a single software user interface that is hardware agnostic, that is used to compute and decipher images that are captured by industrial cameras.
So do you make cameras also?
No, we just make the software. We focus on making the user interface for the software very comfortable and easy for them to use.
Doesn't matter what camera you use?
We do not care about the camera that is used. We care about processing the images as best as we possibly can in the PC. We don't require any specific hardware other than a PC that would run the software. Yeah.
Okay, well, we're here to talk about Scan Tunnel, which is a test bed for vision and vision technology and apparently software as well. Mm-hmm. What are we going to find when we go out? There's a picture of it here. So What are we going to find? I see a mechanical structure here. It looks like it's got a pallet conveyor and maybe 2 elevators.
Yeah, so this system here is made up of 2 different elevators and 2 different pallet conveyors that allow them to circulate pallets in a round continuous motion. And what we can do is we can actually acquire images and use that demo as a pseudo scan tunnel. We can add cameras to it or we can take away. We can add shrouding and change lighting, but we can really use this as a test unit.
So the scan tunnel, I mean, you're separating mechanical from vision, I guess.
Yeah.
So it's really not about the mechanical structure. This is really about the vision technology that we're employing here.
But if we're talking about a scan tunnel, it's really 2 components. There's the mechanical component, and then there's the vision component, what I call. Vision component being the acquiring of an image, setting up the lighting, processing the image, and then disseminating that information out to some supervisory control that would allow a parcel or whatever it is coming through a scan tunnel to be manipulated.
What's the mechanical piece?
The mechanical piece is creating the structure that covers maybe a conveyor in this case, that creates a dedicated lighted environment. Yes, it creates a dedicated environment that allows us to have repeatable images so that we can really decipher and decode images as quickly and as best as possible.
At the heart of this test bed, though, is the vision technology.
Yes.
Okay.
Yes. So we utilize industrial cameras, industrial computing, industrial structures to create the scan tunnel. But
And then your software
simple
is
vision
on this. Okay.
technology.
So we talked a little bit about cameras. You said you were hardware agnostic, I think what you said. There are cameras, though, that already do image processing. It's on the edge processing. They're capturing the image, they're processing it right there on the camera. Are they doing the same thing that your system is doing?
So what they do with an edge device is that device has a computer or a processor internally. It has a program that is used to decipher an image, and it has an image acquisition device or a camera built in. So that camera acquires the image and creates a output to the supervisory system of pass, fail, good, bad, or whatever the results might be. We at Simple Vision Technology created a software interface that will compute and do everything that the edge devices do, but we do it in a central location. So what this helps with is the deployment of multiple cameras or the management of data and the ability to configure all of the cameras and the features and functions in a central location.
You're talking about the cost of scale up or the ease of scale up.
Correct, yes, because you have an edge device that is a fixed price, and so each one is a linear fixed price increase, where when you provide a PC with software and you add a couple of cameras, then as you add these, let's call them dumb cameras that only are used for acquisition, the cost of them is so effective that it really dramatically drops the price.
On our test bed here, smart cameras or dumb cameras?
Dumb cameras. You currently have 4 dumb cameras here, but could easily add another 10 cameras if needed. And not by changing any of the processor or by changing anything else, but really just adding dumb cameras.
Tell you what, let's break here. Let's go out to the lab and have a look at this, and we'll get back together and talk about it.
That'd be great.
Okay, we'll do that.
Thanks.
All right, Mark, we're out here in the shop, and we're next to the test bed for vision and vision processing in your technology, Simple Vision Technologies. We've got an extruded aluminum structure here, and on it's a conveyor system, a belt and pallet style conveyor. There's an elevator on each end of it, and we've got some pallets on the conveyor with some paper that's got some QR codes on it. We're standing next to one of the conveyors, and above the conveyor in the elevator, we've got 2 lights, a red light and a white light, and it looks like we've got 2 cameras. They look identical, but one's got some kind of lens on it or something you'll be able to tell us about. And then we've got a TV screen over here to my left that is showing me what the cameras are seeing, correct?
Yeah, this is the Simple Vision Technology software interface.
All right, so what are we going to be seeing here when this runs? What's going to happen?
So in this demonstration, we have a pallet that is going up and down.
Okay.
And we have...
It's the elevator.
It's the elevator of the demo, and it's identical on both ends, as you mentioned.
Right.
There are 2 cameras.
Right.
One camera has a fixed focal length lens, which means we focus it on a certain plane. And
a certain distance
away from the camera, and that's where it will only be in focus.
So because it's fixed focus, that means when the pallet is in one position, it's going to see it in focus. But as that pallet moves up or down, it's not going to be in focus anymore.
Correct. And so with that camera, we're going to take a picture at the raised position, and it will be out of focus. And then when it fully lowered, the elevator will take another image, and you'll see that it is in focus.
So it's not a motion, it's not a continuous video camera.
No.
It's sending still shots to your technology, correct?
Exactly. And some are in focus and some are not.
So your technology is making the decision on when it's in focus, and then it's capturing that still?
It's capturing the image, transferring it to our system, and then it's deciphering if it can find a code in the image or not.
The content
of that, yeah.
All right, so that's the fixed focal length camera.
Correct.
What's the other camera?
The other camera is showing the technology of a liquid lens.
Right.
So
Are the cameras identical?
the cameras,
Except for the lens?
the cameras are identical except for the lens. Yes,
Right.
correct. And that is a liquid lens. This liquid lens is a technology that allows you to continuously remain in focus no matter what plane you've selected.
So the lens is changing its focal length.
Exactly.
How is it doing that? You said liquid filled. Is that there's a technology there that makes the focal length of the lens change?
There's a technology that it will require a voltage to change the focal length of the
How does
picture
it
that
how
we're
does it know what focal length to have? Is it just continuously moving up or down until it finds the
Nope.
focus?
So what we've done here for this demo is we've provided a laser sensor.
Is that the red dot?
That's the red dot that you see here, that you see on the screen.
It's on the screen there and there. Okay.
And what we're doing is we're measuring the height of the palette so that we can provide a voltage that allows us to stay in focus no matter what plane we're on.
So it's a closed loop system measuring the distance, and as the distance changed, as measured by the laser,
Yes,
it adjusts the focal length on the camera.
exactly. And it has nothing to do with the software. It is really just the closed
It's just
loop.
the lens.
Yep, it's the lens and the measuring system.
All right. And both of these cameras are feeding into a controller in the back of the conveyor here, correct?
Correct, yeah.
And your software is running on that hardware device.
Exactly. Yes, we are hardware agnostic, so we can utilize multiple industrial strength cameras that are very cost effective to install.
When we were in the conference, we talked earlier about edge processing or where the processing is done. Is any of that happening on these cameras? Are they smart devices?
No, so these devices are actually image acquisition only, and they transfer the data or the image directly back to the Simple Vision technology system.
So while this may be what it's seeing, it's not processing any of the cameras aren't processing this data.
Correct. The process data is done directly in the controller where the SVT software resides.
All right. When we start the conveyor up, what are we going to see in the pictures on the TV?
Yeah. Okay. So the top right picture there,
Top right.
yeah,
Yep.
that will be the fixed focus lens. And we'll see that it's out of focus when it's raised, and we'll see that it's in focus when it's lowered.
All right.
And we'll see two different images.
So will I
Still
actually see
images.
this go out of? So this is a still image, right?
Correct.
And
Yep.
and once the conveyor starts moving, it's going to go out of focus.
Correct. Yes. When it's not in the correct focal plane, the image will be out of focus.
And then once it gets in focus, you're saying that then it captures that and it remains the still. That's why it's a still focus.
Exactly.
The bottom is continuous.
Yes, we have that in what we call a live video mode.
All right.
And so we're able to run this camera in a live mode. You'll see as the palette enters and exits that the video will stay live. But what's also going to happen is the elevator will go
It'll
up and down.
always stay in focus as the elevator goes up and down.
Yeah, exactly.
All right. I think we're ready. Let's go ahead and start the conveyor now. So it's
right.
going down,
And we're
out of
seeing-
focus.
And we're seeing
And it
staying in
stays in
focus the
focus.
whole time. Yeah,
Oh, it snapped into focus there.
it did. It's because the fixed focus is at the bottom.
Now, why is it in, I don't know if we can see that, but it's in green there. Why is that in green?
So that depicts that it found a data matrix code. In this demo, we're showing that we can find a data matrix, but we don't necessarily want to find the QR code in this image. So the green is depicting that this is the code that I
This
actually
is what
found.
it was looking for.
This is what I was looking for.
And this is your software on that hardware device. That's not the camera doing this.
Correct. It's all the software that is deciphering the image to provide a result.
Now, this is a test bed, so all we're really doing is looking at pieces of paper. But if this was production, if there was data inside that green box, would that data be sent then someplace?
Absolutely, to whatever industrial controller that is chosen for the project.
Could it do something as simple as checking orientation of a box or of a package on the pallet?
Yes, so the Simple Vision technology software has the ability to do barcode reading, rule-based vision, and artificial intelligence from this central located interface.
Okay.
And so therefore, yes, if we wanted to read just codes, it's possible. If we want to do rule-based vision as well, or any kind of AI inference comparison, it's completely possible.
Now, I'm going to say these conveyors are moving slow, if this is not a fast system, if I had boxes flying down some kind of conveyor, are you going to be able to keep up?
Absolutely, yes. So what we do is we allow the user interface for the user to create these scenarios that allow them to get the optimal image so that they can read the codes that they're looking for.
But if I've got a conveyor that's going feet per second, how fast can these cameras capture the image, communicate it, and then process it?
So depending upon the camera that's chosen, there are multiple frames per second that are acquired. So we have the time to capture images, transfer them to the industrial PC that then deciphers the codes.
In practical terms, even the fastest conveyor is going to be not fast enough to outdo the camera.
Correct. And if required, we can offset some of the triggers. So as a package would maybe come into a scan tunnel, we could look at a sensor that would allow us some delay time.
Here comes a package.
Get ready.
Get ready.
Exactly.
All right.
Yeah.
Mark, this is fascinating. Thank you so much for taking the time to come. Let's go back to the conference room and wrap up.
All right, great. Thanks.
Thank you.
Appreciate it.
Mark, that was fascinating. Thank you so much for walking us through that. I'm still struck by a couple of things. Number one, we're separating the capture of the image from the image processing or the data processing. In my introduction, I talked about data management. Mm-hmm. You're capturing that information and you're processing it. To me, that there's the cost of the scale up and what you do, but there's also the concept of speed. Can you be fast enough? Our conveyor, we're moving slow because we're showing the vision technology.
Sure.
But if I wanted to shoot a baseball through the vision tunnel, I know it's not set up, but if I had that, could you capture a number that was on that softball?
Absolutely. With the user interface giving the customers the ability to set up the system, it's possible to set up a pre-trigger. So I could really look at the velocity of what the ball is moving, and then I could tell you how long it takes to get from the switch to the proper location in front of the camera, and I can acquire the image with a global shutter, which allows me to do a very still, crisp image that is in motion. And this would allow us to provide a very good image based upon whatever speed that we're sending. So there's no problem in actually capturing the image. Processing the image, because we're on a central processing unit, is much faster than it would be on an edge device.
And if you wanted to replicate this, or if you wanted to increase this or add another line, do we just have to add another SVT software device, or is there an upper limit on the cameras that you can connect to this?
So each license allows you up to 25 cameras.
25 cameras.
Exactly.
Okay.
And so therefore, in this example, we could potentially add another 21 cameras to this system with no need for another license even, or no need for another processing unit. So scalability is very cost effective.
What does the future look like? Where is the software going? Where is the hardware going? In 5 years from now, are we going to be doing this the same way? Is artificial intelligence going to become more involved in this?
Absolutely, artificial intelligence is going to become more and more involved. But I think where this scales at a very interesting level for customers is that an edge device, when deployed, is a fixed processor with a fixed camera resolution. As technology changes rapidly in this market, processors are faster, image acquisition is faster, megapixel resolution is much higher and higher.
But that's more data.
That's more data, but the software is the key to transferring that data. And so as the cameras advance, so will the PC, and as long as the software is capable of transferring that data, then we're good.
As we talk about the scan tunnel, this test bed has been a great vehicle to show this, but there's more questions that I have about your technology. I think I'd like to have you come back and we just spend a whole episode talking about simple vision technology. Would you be open for that?
That'd be great. I would love to do that. Yeah, explain a lot more about what we do. That'd be fantastic.
You know, I really appreciate your work and your help here in walking through the scan tunnel and how the images work and the data management piece of it. Thank you so much. I appreciate your time.
Thank you. Thanks for having me.
No problem. To learn more about Simple Vision Technology, visit simplevisiontechnology.com. To learn more about Evolution Motion Solutions, visit evolutionmotion.com. Don't forget to subscribe to Evolution in Controls on whatever platform you use for podcasts or on YouTube for a video version so you can be updated when we release new episodes. Thank you again for joining us today. I'm Tim Wilson, and remember, keep moving.